Okay, so this is the first time I've used Open Broadcast software. This thing right here, Open Broadcaster software. Ooh, yeah. Um, and so I'm really hoping I got all the settings right. And yeah, so let's jump on in here. Now this is a Lua, debugger. It's through Eclipse. I'll of course, give you the link in the description for using this. Highly recommend it if you're planning on building some larger, more complex Lua programs. It's really great to learn it for computer craft and all that good stuff. So yeah, you just download it, and I think it comes down to a zip, and then you just open up the executable with this symbol right here. To all you Mac users out there, you're out of luck. I'm sorry. There might be something out there for you, but sorry. All right, so let's get into this program. Um, so yeah, this is the 8th version of the program I made. The program will maintain several flux grinders arranged around it. You can specify the number of grinders and their positions. The program expects each grinder to have a dedicated energetic infuser. Program will detect if a tool in the autonomous activator is below a preset charge threshold and send it to the energetic infuser if it is. Yep, I should make instructional videos all the time. Okay, so in the setup here, this is what you really want to go change. And I'm going to go through this program the same way that I would recommend you go through a program that you don't know, which is where you start with up at the top where variables should be declared, and then you jump down to the main function and then just sort of work your way backward through all the functions that it calls. So here in the setup, this is what you want to look at. The lag buster here does what it says right there. It's how long it waits between each operation. So rather than having it go every single second or whatever, or 5 seconds, whatever, because the tools aren't discharging that quickly, we can wait 10 seconds or even longer. So this could be like a minute or 2 minutes or something, anything you want in there. And then I like using tables. That's a new thing I've started doing with Lua because Lua is really powerful when you use tables. So I've made a table called device info, and then I'm going to just create a bunch of different fields within that table. So this one is num devices, master threshold, so on and so forth. So basically you can tell it how many devices it has. And that can be anywhere between 1 and 6. You could go higher than that for some reason. I don't know why, because there's not more than 6 sides to a cube, but yeah. So you can tell how many devices are attached to the computer, and then you can say, okay, what's the master charge threshold when the tool within the device, within the autonomous activator, gets below this percentage, then go ahead and send it to the charger. And then we say, where is the tool located? I don't know why it'd be different than 1, but if you want to customize it, I give you the option to. Okay. And then I've also gone through and just said, okay, let's also add some extra fields to this. Let's add, an array style to this, so I can say device 1, 2, 3, and then individual fields for that. So that's what this for loop is doing. Or 1, 2, 3, 4, 5, 6, so on and so forth. Now I need to say where the flux grinder is in relation to the computer, so it knows which one it's talking to, or I guess where the autonomous activator is in relation to the computer. So that's for 1, 2, 3. I initialize them all correctly. This would be wherever it is for you. Yeah. Now, where is the energetic infuser in relation to the autonomous activator? And this is cardinal directions, so north, south, east, west, and of course up and down. The initial program I did had it all below it, but now I've changed it so that they're on the north and the south sides, as you saw in the previous recording. If you really, really want to, if you had some sort of setup where it's managing more than one autonomous activator with a tool in it at once, like let's say for harvesting crops and killing animals or something like that, and you had 2 different types of tools, maybe you want to have one with a 1 charge threshold, another one with an entirely different one. So here, if you really want to, you have that option, but you don't have to change it. If you don't want to, you can just leave it grabbing from the master threshold. Same thing with these tool slots. If you really wanted to change the tool slot, you could here as well. Okay. So then that's pretty much all you need to worry about for customization. From here on in, the program takes care of itself. So here what I'm doing is I'm wrapping the devices, so I do another little for loop. I've made another table called devices. First one was called device info, the second one's called devices, so these are the actual devices, and I'm wrapping them into this array. It's in slot I, so it's going to be like, there's 3 devices, it'll be slot 1, 2, 3, or so on and so forth. Down here in the functions, well actually let's go down, okay. So let's go down to the main function. Okay, look, I found the main function. Run program, woot. Where's main? Let's see where it gets defined. Look, it's defined up here. Awesome. So the main function, it does everything. So first time, we keep track of how many times we cycled because we want to display the number of cycles on it. So we have a local variable called cycles. Then we start an infinite loop so that we always are doing this. Now we cycle through the connected devices and attempt to charge the tools. So we have another for loop set up here. We say device info.num_devices. That way we can have any number of devices again. And then I grab the string that says what side it's attached to, so I'm printing descriptive statements onto the monitor. You know what's going on. Now I want to inform the user what's going on, so I'm checking into full tool in the device. Then I have a space, so it prints all nice and correctly. And then I append the temp side string onto that. Another space with a little ellipse, a little dot 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 to make it just look cool. Alright, so now I check if the tool needs charging using a function called I store it within a local variable called temp condition, and the function is check and send I. So I is from this for loop right here, it's the iteration I'm on, so check and send. Let's go find out where check and send is. So I scroll up, you can see with this program it highlights, here's check and send here, and it highlights it up there, so it's very easy to find. Alright, so what's check and send do? Checks if a device needs charge, sends it to the charger if it does, returns true if sent to device, false otherwise. So, check and send, and it asks for the parameter device number. So that's what I'm doing on here. The number of iterations I'm on. So the first, second, or third device up here, I'm sending that. So if check below threshold, device number then. So where's check below threshold? Let's go find that. Oh look, here it is. Returns if tool is in device is below the threshold, false, and returns false if there's no tool. So it turns false both if the tool does not need charged and if they can't find a tool. That way that we don't handle conditions improperly and we don't throw errors. So this guy basically is also asking for the number, and then it's also saying get charge percent. Okay, where's the get charge percent? Oh look, I found it. This one's asking for brand new, so it returns the percentage of energy in the tool, and 100% if it doesn't find a tool. Again, that's just to handle proper errors. So the tool info here, that's what it's asking for. So I get that down here where I pass it. So if check tool in device, oh boy, we got another one. So let's go up to check tool in device. Where's that? Here it is. Checks if the tool is in the device by checking if info exists, returns boolean. Again, I'm doing all this super recursive, making sure the tool's there and handling the errors properly, just so that the program doesn't crash if anything gets shifted around in the autonomous activator for any reason. And also while it's charging, of course, it's not going to be in the autonomous activator, so I don't want the program to crash then. So I'm just very robustly making sure the tool is in the device, and if it's not, I'm handling those errors properly. So, check if the tool's in device. It also asks for tool info. If not tool info, so meaning if nothing is contained within the variable tool info, it will be nil. It'll be equivalent to nil, which Lua handles as false, which is unique in well, it's not entirely unique, but it's a lot of other programming languages don't do that. Java and C both don't treat nil as false. They don't treat it as a boolean, equivalent to a boolean. You'll throw an error if you check if equal to nil. Be like, no, it's not equal to nil. So here we can actually do. So if it's nil, say if not nil, then do stuff. That doesn't make sense, does it? If not nil. Oh, no. Okay, if there's not item info in here. So, yeah, then there's no item found, otherwise return true. I had to check that again for myself. Run through it in my brain for a second. Alright, let's go back down to where we were. Here we are, check the tool. So we're not checking the percentage if there is no tool, because that way we're not mapping an invalid device location to, we're not trying to store something that doesn't exist into a variable. So we're just making sure there. So here I'm doing return math.floor. That's basically saying round down. So if I have 3.129, it'll cut off all the decimals and just return 3. If I had 59.6, cut off the 0.6 and just return 59. So it basically drops anything after a decimal point. So basically I'm saying, okay, tool info, so info about the tool, dot energy stored. This is a field from Open Peripherals. Open Peripherals allows you to access certain NPT data about items, and thermal expansion with flux adds a field called energy stored that you can get information about. And then also, same thing here, adds another field called max energy stored, and obviously percentages, as you take the current divided by the max, and then times by 100, and that gives you a percentage. Hooray! And then math.floor, again, just drops the percentage. And then otherwise, remember 100% if there's no tool. So if there is no device, then I just return 100. Alright, so where was I doing that? Down here. Right here. I was right there. So, how do I get these tool references? Because this guy needs tool reference. Well, I have a function called tool reference. So let's go find it. Oh my gosh, there it is. So you pass it the device number that we're on, so 1, 2, 3, 4, whatever, in that array. And then it returns devices, and then the array number, so 1, 2, 3, 4 again. So that way you access the proper location within the array or within the table or whatever you want to call it. And then we access the field. There's also a thing with open peripherals where anything with an inventory, the way you get information about that particular slot in the inventory is you say get stack in slot. So great, I'm asking for get stack in slot. And of course I need to know what the tool slot is. So remember in device info, this is where I stored it. It was within the table called device info, and of course this is accessing the proper location. And then the field was called tool slot. So great. Hooray, that's how I'm getting tool references. So I don't have to type. The reason I have this broken out into its own function is so I don't have to type this line every single time, because that would be very annoying. Alright, so we were down here. Boom. Alright, so if charge percent is less than my threshold, remember we're going to set the threshold up top there? Yeah, if it's less than the threshold, not if, it's just returning. No, that's true. It's returning if this is true or not. So basically it's saying it'll return true if this statement is true, it'll return false if this statement is false. So that's just a really quick, easy, one-line way to do it. Alright, so where did I call that? Not send to charger, check and send. So there we go. Check below threshold, that's where we just were. So if check below thresholds, remember that turns true or false. Then, so if true, then do this. Otherwise, nothing. Right? So if you need to do it, then I return send to charger, because send to charger, basically what it does, it also returns a true or false, because I want to be able to tell if it actually worked. So that's why I'm returning whatever send to charger returns. So we go up here to send to charger. Again, it's remembering what the tool reference is, so I can use it. And then if the tool is in the device, we don't need to go look at that again, so we know what it does. Then we attempt to push the item into the charger. And this push item right here, this guy is also from Open Peripherals. It returns the number of items pushed. So if it pushes 1, it returns 1. If it pushes 64, an entire stack, it returns 64. If it doesn't push anything, it returns 0. So that's basically the way you test if it worked or not. So I store that type of information, so 0 through 64, in success here. And then basically I say I'm asking devices. So remember I wrapped all the different peripherals into a table called devices, and this way I'm accessing the proper field. Push item, and then this is the order the open peripherals needs. Basically needs what side the other inventory is on, so that's why I have the .infuser side. And then it needs the slot within the current inventory that I'm trying to go to, and then the number of devices I'm trying to send, and then the the number or the slot within the other inventory I'm trying to send to. So that's the way that works. And then I return success not equal to 0. So if success is not equal to 0, meaning 1 or higher, that means it was successful, so this statement would return true. If it is equal to 0, this statement would return false. So basically, if it was successful, return true. If it was not successful, return false. And also, if there was no tool found, right here, with this check tool and device statement, then we return false as well. Great, so that was just the send to charger guy. Where did that happen? Right there, send to charger. So now we're at the check and send, which means we're all the way down here. Check and send, great. So we're back inside our main function. Great, so that's the way I like to go through programs, is see how we sort of just this one little check and send guy dove us backwards 6 or 7 functions. and force us to understand what they do. I personally think that's the easiest way to look through code, is to recursively go backwards through the way the program's actually calling the functions to see what they're doing, instead of trying to read all the functions without any context and memorize what they do, and then going back and then trying to remember what they do within the program, because your chances are you're going to have to go back and check again, so you might as well do it you might as well not leave out that extra step and save yourself some time. All right. So I store if that worked or not. So true, it returns true if it sent it. It returns false if it didn't. So that temp condition thing. And remember, it would be false if it doesn't need charged or if there's no tool in the device. So if temp condition, so if it sent it to the device, I tell the user. So charging the tool from, remember, stored that side. So I print it there. So charging tool from left, right, down, back, whatever. Charging tool from left device. Or bottom, I guess is how it is here. Yeah, so else, so if it returned false, meaning there was no tool or didn't need charge, I let them know that. So no tool in left device, or the tool doesn't need charging. No tool in bottom device, or tool doesn't need charging. So that's basically something, if it's not really working the way you expect, but it's not throwing an error, if it's not crashing out of the program, this is one way to sort of debug it for yourself to see what the program's thinking. And then I put a delineation between the end of the cycle. So basically I put a nice little line across the screen, because the screen has 51 characters, so I have 51 dashes. And then I print the end of the cycle, comma, and then I convert the number into a string, because that's the way Lua likes you to do it, is it can print the thing directly, but when you start getting longer integers or longer numbers, then it likes you to convert into a string. So if you ever get into the millions of cycles, which I doubt you ever would because the server restarts, but if you ever do for whatever reason, this is the way to do it. You need to do a toString. You also have, if this ever contained nil, it would say end of cycles, comma, nil. If you didn't have that toString there and it was a nil, it'd say end of cycle space and then nothing. There wouldn't be anything printed to the screen. I'm going to add one to the cycle number. Let me get a drink here. Quenching. And then here's where I take it into account that lag buster thing. So here I'm sleeping for 10 or seconds or 60 seconds or 120 seconds or whatever you set it to, so that this program doesn't lag your server by constantly checking if the tool needs charging. Because again, you don't need to constantly check if the tool needs charging. So that is what this program does. Yeah, hopefully that all made sense to you. Hopefully I explained it to you. I believe I've commented this program pretty well, so if you didn't understand it, you can always download it from pastebin. You saw that link in the program, or sorry, in the video. Of course, the link will still be down in the description. Also, again, the link for this particular Eclipse plugin will be in the description. You can run it as a standalone. I would recommend just downloading the standalone version. In fact, you know what, screw it. I'm going to put the link to the standalone version in the description just to save confusion. And again, I think it comes in a zip. I don't remember. It's been a while, but either way, either from within the zip, or if it doesn't come in a zip, you just run the executable with this particular icon, this reddish icon. Yeah, it's even bigger down here, so you can see it better. All right, great. So I think that's that. Anything else I need to talk about? I don't think so. So yeah, links and stuff in the description. Got to remember to do that. All right. Well, thank you all very much for watching, and I'll catch you next time. All right. Bye-bye.